Evaluating the following integrals with 4 examples. Let's get started. To evaluate the following integrals, we'll take one by one. Let's go for part A. Here's part A. To do this, we can't use substitution. We have to do the distributive property and make it a standard form of polynomial. So we have the following equal to the integral from 0 to 2 of 8 2x times 4x to the second, that is 8x to the third, minus 12x to the second plus 2x minus 3, all with respect to x. Next, 8x to the third will be 8x to the 4 over 4, and 8 over 4 will simplify to 2, and that's 2x to the 4, minus 12x to the third over 3, that is 4x to the third, plus 2x to the second over 2, which simplifies to x to the second, minus 3x. Since we have limits, we don't write plus c. We go from 0 to 2. We plug in 2 first, and that will give me 32 minus 32 again, plus 4 minus 6. Plug in 0, you get 0 all over, and that's minus 0. Doing the math, 32 minus 32 cancels. 4 minus 6 will give me minus 2, and that should do it. That's for part A. Let's go for part B, and we have the following. Integrate 5e to the x plus 3 sine x with respect to x from 0 to pi equals 5e to the x will be the same because the integral of e to the x is e to the x minus 3 cosine x. The derivative of cosine is negative sine, so we need to show the minus, as you could see. In other words, the derivative of minus cosine is positive sine. And of course, we need to plug in 0 to pi instead of writing plus c, because it's a definite integral, not indefinite integral. Plug in pi first, then plug in 0 and subtract. That will give me the following. 5e to the pi minus 3 multiplied by cosine pi, and cosine pi is negative 1. That's cosine 180 degree. Plug in 0, get 5e to the power 0, and anything raised to the power 0 is 1, so that's 5 times 1 plus 3 times cosine 0 is 1. Doing the math, we have 5e to the pi plus 3 minus 5 minus negative 3. That is, this right here is a typo, so let's fix that. That should be a minus. This is a minus, as you could see from here. Okay, so going back, that's a plus 3, because minus minus will give me a plus 3. Doing the math, we have 5e to the power pi, 3 and 3, 6, 6 minus 5 is 1. The answer is 5e to the pi plus 1. And that should do it for part B. Let's go to the third part. Integrate from 1 to 4 of 4 plus 6x divided by square root of x. One more time, we can't use substitution here. So we're going to distribute 4 plus 6x divided by square root of x. That will be integral from 1 to 4, 4 divided by square root of x, and 6x divided by square root of x. That's called distributive. Equals, writing it in powers, integrate from 1 to 4. Square root of x is x to the power half. Move it to the top. That becomes 4x to the power negative half. And 6x to the power 1 divided by x to the power half. Subtract exponents. 1 minus half is half. 1 minus half is half, so that's going to be 6x to the power half with respect to x. Now let's integrate. We increase the exponent by 1 and divide by the new exponent. Negative half plus 1 is 1 half. That is 4x to the power half divided by half, or 4x to the power half times 2 over 1. And that will give me 8x to the power half plus 4x to the power 3 over 2 after we add 1 to half and make it 3 over 2 and dividing by 3 over 2, which means multiply by 2/3. 6 times 2/3 will give me 4. And we need to plug in the numbers 1 and 4 instead of writing plus c. That will give me 16 plus 32. That's after you plug in 4. Minus plug in 1. 8 times 1 to the half is 8. And 4 times 1 to the power 3 over 2 is just 4 times 1. And that's 4. Subtracting and adding, that is 36. Okay, now we come to the last part that has a sine and sine square. So, to do this, we know that sine square plus cosine square, of course with x, equals 1. Subtracting sine square from both sides, right here, or move it to the right side, either way, minus sine square x. This one cancels, and we end up with cosine square x equals 1 minus sine square x. So this portion right here is this right here. So the problem becomes integral or integrate sine x over cosine square x with respect to x. We could split this into two parts. That is 1 over cosine x multiplied by sine x over cosine x with respect to x, which means that is 1 over cosine x, which is secant x, and sine over cosine, which is tan x, all with respect to dx. We know that the derivative of secant is secant tan, so that will give me secant x by itself. Of course, this time we don't have limits, so we have to include the c. And that should do it.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.